Hi everybody, Mr. Martinez here. I hope you're having a good day. I'm going to go over the homework key for the area of regular polygons. So this is number one. Number one, what is the area of the regular polygon? So because this is a quadrilateral, this is a specific quadrilateral that is a square. So we call this a square because all four angles are congruent and all four sides are congruent, which means it's a square. A rectangle does not have that. A rhombus does not have that, nor does a parallelogram, nor a trapezoid. Okay, so we know that from here to here is the apothem, and we know that's the apothem because this is the center and it's perpendicular to one of the bases. So we actually have two ways to find the area of this. Since it's a square, we know that the area of a square is base times height. And even though we don't know the base nor the height, we can figure it out. So because this is 5 from here to here, we know that if we also draw the apothem from here to here, that's also going to be 5. So we have the height of 10. So the height is 10. And then the base, and I'll make the base in blue. The base, well, remember that a square has the same side length. So if the height is 10, the base is also going to be 10. So this base is 10 from here to here. So that's one way to do it. So 10 times 10 inches, that's going to be 100 inches squared. So that is only because this is a square that we're able to do that. So because this was a square, we knew that this apothem is the same for this apothem, and then that gives you the side length of the square. However, that is not true. For example, for this one, I cannot do this because that is the height of the whole hexagon. It is not the side length of the hexagon. So notice the difference here. Here it just so happens that the height is equivalent to the side of the square. However, it is not equivalent the height to apothems, or the height of the hexagon is not equivalent to the side of the hexagon. Okay, so let's go ahead and do it using the area of regular shapes because we need to understand how to do it that way too. So even though we can use the area of a square, it's good for you to practice that, but it's also better for you to recognize that we need to find the area of the regular. So I'll put REG. Okay, so the area is going to be apothem times the height, apothem times perimeter divided by 2. So what we're going to do is we need to find what the apothem is, and we need to find what the perimeter is. Well, we already know what the apothem is. The apothem is 5. So I'm going to go ahead and label 5 times the perimeter. We need to know what the perimeter is. We can use this to help us find the perimeter. So if we draw the radii, let's draw 2 radii. And remember, the radii go from the center to the vertex, center to the vertex. Then we can find the side of the square, which would then give us the perimeter. In fact, I'm going to draw all 4 radii. That way we can see what we need to do. What we need to do to find the side, which will then help us find the perimeter, is we need to solve for the central angle. Now, you can think of it this way. 360 divided by 4 congruent central angles is 90. So we know that that middle angle is going to be 90. I'm going to do it over here, 90 degrees, 90, 90, 90. When we draw the apothem, this is going to be 45. So we have a 45, 45, 90. Okay, so I'm not going to review it like I normally do in the videos. You can look back in the videos. Okay, so across 45, we have a 5. Across this 45, we have a 5. Just to practice, we don't really need it, but just to practice, across the 90, we're going to have 5 radical 2. We do not need it for this question because it is not asking us for the radius. It's not asking us for the radius, but we're just going to practice it anyway so that we can review. Okay, so we know that this length from here to here is 5. And because this is an isosceles triangle, it's an isosceles triangle because these two blue sides of the triangle are the radii. So since this side is congruent to this side, we know that this point, when we draw the apothem or altitude, is the midpoint. So therefore, we know that this side is congruent to this side. And I went over that in the video, so that should be a review. 5. So now we have the whole length. The whole length is 10. And then we know that 10 times 4, because we want the perimeter, 10 times 4, because there's 4 sides, is 40. So 40, that's the perimeter, and we are going to divide by 2. So half of 40 is 20. So 20 times 5 is 100, which is what we found earlier using just the area of a square. Okay, so area of a square works, area of a regular polygon works, but remember, this just so happens to work for the square. It's not going to work for the other shapes, only for the square. Okay, number 2, what is the area of the regular polygon? So this has 1, 2, 3, 4, 5, 6 sides. So we need to find the apothem, and we need to find the perimeter. So what I'm going to do is I'm going to draw in all radii. So go ahead and grab your ruler, draw in all radii. Once you've drawn in all the radii, remember radii go from the center to the vertex. Then let's go ahead and figure out what we do know. So we know that the perimeter is going to be 3 times 6, because there's 6 sides. So 18, that's the perimeter. We need to figure out the apothem. And the apothem goes from the center to the side, one of the sides of the polygon. So we need to know what A is, or apothem. Okay, as always, we're going to figure out what the central angle is. So this central angle here is 360 divided by 6, because there's 6 congruent angles, 1, 2, 3, 4, 5, 6. So that's going to give us 60 degrees. 360 divided by 6 is 60. So that means when we draw in the apothem, this is going to be 30. And again, I'm going pretty fast here because this should all be a review, since hopefully you saw the video last week and the video that I posted on continuation of area of triangles, area of regular polygons. So make sure you take a look. That's where I go a little bit more slower. Okay, so this is 30. In fact, this is also 30 over here, but we're just going to focus on this triangle over here. So we know that this is a 30, 60, 90. So we just need to know the apothem. That's all we need to know. We do not care about anything else, but we're going to practice though. We know that one side is 3. Half of 3 is 1.5. So I'm going to put 1.5. And then that's going to help us find the side across the 60. The side across the 60 is 1.5 times radical 3. Okay, that looks confusing, but not a big deal. The calculator will handle everything. Okay, boom, we're done. Just to practice, across the 90, we're going to have a side length of twice of 1.5, which is 3. And again, that makes sense because when I asked you to construct a hexagon, a regular hexagon, we did 6 we constructed 6 equilateral triangles. So that makes sense why this should be 3. All right, so apothem, I'm going to put it in red because that's what we color coded it, is 1.5 times radical 3. Okay, so now we're going to use our formula. Perimeter, area equals perimeter times the apothem divided by 2. Now, again, you can use your calculator. I encourage you to use not your phone because it can look very confusing on the phone, especially on the iPhones. You need to type it in a certain manner. So I'm going to go ahead and use Decimals calculator. So 18 times 1.5 radical, or square root, I should say more specifically, square root of 3. Now I want to put parentheses around the whole thing because I want, what I want to happen first is for the 18 to multiply to 1.5 radical 3. And then I'm going to divide the product by 2. So the area is this value, 23.38 units squared. Okay, that is the area of the hexagon. All right, number 3. What is the area of the regular polygon? This is a equilateral triangle. Okay, so if you try like the square where we just kind of went up and we figured out the side, it will not work, and I'll show you why. This right here is the radius, because it's going from the center to the vertex. You might think that from here down is also a length of 2, but that is incorrect, because this is the center and this is going to a point on the side, not the vertex. So this right here is 2. This down here, vertical, is the apothem. So the apothem is not 2. So that is incorrect. If you did that, you want to make sure you catch that. Okay, so what I'm going to do is I am, however, going to draw in the apothem for this part, for this side, I should say, for this side. So the apothem goes from the center again to the point that intersects the side, and it's perpendicular. Okay, what is the area? So again, area is perimeter times apothem. So P, we do not know what that is. A, we also do not know what that is, but we do know what the radius is. And I'm going to put the radius in blue. So the radius is 2, and the radius is going to help us. So what we want to do is, let's go ahead and create that isosceles triangle. So the isosceles triangle is created by 2 radii. Okay, so there's the 2 radii. This is 2. But I want to focus on this bottom triangle. So again, just because it's easier to work with a horizontal base rather than a diagonal base. So that's why I am not focusing on this triangle. Okay, I'm going to focus on the bottom triangle. Okay, so I know that that's 2, and I know that this is also 2. So there you go, 2, 2, 2, the radii. So that's going to help me find the apothem and, in fact, the perimeter. So what we need to do is we need to find the central angle. So this central angle and this one and this one, they're all congruent. So 360 divided by 3. 360 divided by 3, think about what that is. That's 120. So each central angle is 120. Now when we draw on the apothem, we have half of 120 is 60. So look at that. We have a 30, 60, 90. Okay, when we have a 30, 60, 90, that's going to help us find the apothem. So right now this is across the 90. So half across the 30 is half. So across the 30 should be 1, and that is the apothem. Look at that. We found the apothem. Okay. So now we can find the this side, or half of the base side. So from here to here, that is across, this is across 60 degrees. So that's going to be 1 radical 3. 1 times radical 3 specifically. Okay? All right. So that's going to help us find the perimeter. And we're done. We're almost done. I mean, finding, all the missing parts. We just need to find the whole length. So the whole length of one side is 1 radical 3. Remember, that's the midpoint of the base side. 1 radical 3. All right. This is a sum, which means you add. Okay, we did that earlier. 5 plus 5 gives us 10. So we are going to do the same thing for this one. 1 radical 3 plus 1 radical 3. Think about what that is. It is not radical 6. It is also not radical 9. This is 2 radical 3. So think of this as 1x plus 1x. So replace the radical 3 with x. So 1x plus 1x, that's just 2x or 2 radical 3. Okay, so some algebra right there. All right, so that is the length of one side. However, we want to know the perimeter, which means you go all the way around. So the perimeter is going to be 2 radical 3 times 3 because there's 3 sides. More algebra. Oh man. All right. So 2 radical 3, and then I'm going to multiply that by 3. So take a moment to think about what that's going to be. Okay. So the perimeter is going to be 2 times 3, which is 6, times radical 3. You do not multiply the 3 by the radical 3. Only the 2 and the 3. Okay? Or you can think of it 2 plus radical 3 plus 2 plus radical 3 plus 2 plus radical 3. All right, now we have all the information. So let's plug and chug. So let's see. The perimeter, 6 radical 3 times the apothem. The apothem is 1. So, you don't really need to write it, but I'm just going to write it to make sure that we understand that we're multiplying by the apothem. I'm going to turn this into a dot. Okay, so perimeter times the apothem, and the whole thing is going to be divided by 2. All right, so let's do some algebra. 6 divided by 2 is 3. And then this is 1. Boom, that's it. So the answer is 3 radical 3 meters squared, because this is area, so we need to put the units. Okay. In fact, for the other ones I forgot, this is going to be feet squared, and then this is going to be inches squared, which I did. Okay. Number 4, what is the area of the regular polygon? So let's see. This is, again, a hexagon. It has 6 sides. So we need to figure out the perimeter. We know the apothem. The apothem is 4 radical 3. So hopefully you're kind of seeing the pattern here. We are always going to start with something. We're always either going to start with the perimeter, or with the side length, or with the radius, or with the apothem. So one of those are going to be given, and then we'll have to find the other parts. Okay, so let's see. I always draw in the radii because the radii is going to help me find the missing parts. And specifically, what I want to know is the measure of this angle right here, this center angle. Now, if you remember, we did it earlier. 360 divided by 6, because it's a hexagon, is 60 degrees. So this right here, this angle right here is 60 degrees. I am not going to draw out all 6 triangles. Okay, I'm only going to draw one of them. So you can draw all 6 if you prefer. I'm not. Okay. Half of 60 degrees is 30. So this is 30. And again, we have a 30, 60, 90. So that's coming up. So, you have to make sure that we understand that. So 30, 60, 90. So across the 60 is 4 radical 3, which happens to be the apothem. Across the 30 is going to be just 4. So this is 4. This part, or half of the side. So that means that the whole side is 8. Okay? And just to practice, the radius, it's not asking us for the radius, but just practice, across the 90 is going to be twice of this number, which is 8. Okay, so we now can figure out the perimeter. The perimeter is going to be 8 times 6, because it's a hexagon. 8 times 6 is 48. All right, we have everything that we need to find the area. So let's go ahead and put it into our notes or calculator, or whatever you prefer. I'm going to go ahead and always start off with by hand because I think it's great to practice our algebra. That's how you refine it. That's how you become resilient. So think about it. 4 divided by 2, probably not the best way to do it. Better to divide the bigger number by 2. So half of 48 is 24. This becomes a 1. Okay, so now you have 24 times 4. All right, so you can use a calculator or you can do it by hand. 4 times 4 is 16, carry the 1. So you know you're going to have a 6. 4 times 2 is 8, plus the 1 that you carried is 9, so 96 times radical 3. That's it. You are not going to multiply the 24 by the radical 3. Boom. Unit squared. They didn't give us any units, so unit squared. All right, that's it. That is the area. Okay, number 5. What is the difference between a radius, the radius is in blue, and an apothem? The apothem is in red. Take a moment to think about it. Okay, radius, center to vertex. Apothem, center to the midpoint of the base or a side, and it is perpendicular. These two are not congruent. They are not congruent. So similar to here, the red one is the apothem, the blue are the radii, and I went over how the radii is not congruent to the apothem. In fact, you can see here, the radius is 2, the apothem was 1. That's what we figured out for the apothem. So that's the difference. You got to pay attention. Apothem goes to the base, midpoint. Radius goes to the vertex, corners. That's the difference. And they usually have different lengths, almost always. Number 8, find the measure of each numbered angle. Okay, we have an equilateral triangle, so we know to find the measure of a central angle. And the central angle, again, you draw in the radius, and we just went over it. Center to vertex, center to vertex, center to vertex. That's going to go ahead and tell us or highlight the central angle. So 1 happens to be the central angle. So we're going to do 360 divided by 3 because there are 3 congruent central angles. Okay, so 360 divided by 3. Now think about what that is. 120. Boom, we're done. 120 with at least angle 1. All right, angle 2. Okay, this is the apothem, and we know it's the apothem because it goes from the center and it is perpendicular to the base. So we know that that is the apothem. So we know the whole thing is 120. So half of 120 is 60. So the measure of angle 2 is 60. By the way, this is great practice because that's usually what we do when we find the area of any shapes. That's what we've been doing in all these other examples before. All right, so this is 60. 60 plus 90 plus 30 is 180. So the measure of angle 3 is 30. Okay, so it's a 30-degree triangle, 30-degree angles right here. All right, last one, number 9. Find the measure of each numbered angle. And again, this is a regular, quadrilateral, or a square. All right, right off the bat, you can figure out what this is, angle 4. When diagonals of a square cross, that's going to be 90 degrees. Let's say you forgot that. It's okay. Draw on the radii like I have. 360 divided by 4, because there's 4 congruent central angles, angle 1, 2, 3, and 4. Okay, so that's going to give you 90 degrees. So angle 4 is 90. Boom, done. All right, when you draw in the apothem, we're cutting this angle, angle 5, and when we draw in the apothem, we're cutting this central angle right here, which is 90. We're cutting it in half. So half of 90 is 45. Boom, done with angle 5. All right, now we have a 45 plus 90 plus 45. Boom, we are donezo. All right, everybody. Thank you for joining in. Have a great rest of your day. We'll catch each other soon.